I'm now showing a slide of a traditional stormwater management system, and it's not really just stormwater management. If you see this, showing a catchment of which letters A through to G and H, which might be a city, say Brisbane or Melbourne or parts of a city. It's got some traditional drainage system, which is pipes and so in there that are taking the runoff from roads and properties, including your house, and putting it into an urban waterway. And eventually at the bottom of that catchment, there'll be a constructed wetland or a detention basin that takes the water and slows down the flows before it enters a river or a waterway or receiving water. But at the same time, that urban area is taking water from a catchment somewhere else, usually a rural catchment, which farmers and others rely on for water supply. So by doing that, it's actually changing the environmental flow regimes in the river below that rural catchment, and it's actually the city's taking water from the rural area. So there's actually a hidden trade-off going on here that people are not aware of. And if your city is struggling for water supply, and it's only reliant on dams, it may also be reliant on desalination from an ocean, which is fairly energy intensive, to supplement that supply. Also at the bottom of that catchment and throughout that catchment, there's a wastewater system, and wastewater systems, surprisingly to most, are actually designed to carry stormwater. So they have a peak design. And these systems are cumulative, so the red hydrographs, as they're called, with the first one is allotment, is the shape of the stormwater runoff that will run off one property, say your house, and then there'll be further down the system, you've got two houses coming together. This is the red shapes, red graphs, so then you've got two volumes of water coming together. And then as you go down the catchment to the sub-catchment, that shape of that and the volume is greater until you get to the bottom at point D, where it's actually society's trying to manage this thing. You get a large volume of stormwater that enters that system. So these graphs are volume and time, which engineers call peak discharge. But as you can see from those shapes, there are a volume of stormwater that we're attempting to manage. So in the essence, this slide is all about an integrated system we're trying to manage, which stormwater is part of. And when we live in an urban area, we're actually taking and relying on resources from other areas, including rural areas and so on. So if we're managing stormwater, say using rainwater harvesting, we're actually changing the impacts on other people's catchments, for instance those where farmers live in potentially, and changing impacts on the energy system by demanding less desalinated water. This slide shows something that is quite important in an urban area or in any infrastructure equation, but let's just say the stormwater system in your urban area, it's built to perform in a pristine manner, but throughout time its condition deteriorates, which is the red line on this graph. It's known as the structural condition, and age on the bottom of the axis, on the horizontal axis. So over time, the condition of the asset, in this case it'll be the pipes and the inlet pits and the road asset and the curb and channel that discharge this stormwater from your urban area to a catchment to protect you from nuisance and property damage. It loses its capacity to do that over time, which is shown by the hydraulic capacity shown as the green line. So after about 30 years, there's a strong decline in the capacity of the system. And that's actually created by blockages for tree roots. Most of your stormwater systems are butt jointed. They move because soil moves. They become blocked and misaligned. There's all sorts of issues that go on with them over time, including become cracked, that changes their ability to perform. So one of the opportunities with rainwater harvesting is, rather than go out and build a whole new set of infrastructure because your infrastructure is getting old and losing its ability to perform, you can actually change the volume of runoff that's entering the system so that you don't have to replace your ageing infrastructure.
So Peter, that slide you're showing that after 30 years, the performance of the stormwater system actually decreases quite sharply, and then really reduces down to something like 40% over 100 years.
That's true. So obviously the new stormwater systems are good for 20, 30 years before they start changing their performance, and then the decline is reasonably rapid, which is expected. We should also add, when looking at this graph, say in the city of Newcastle, the average age of their stormwater drainage system is about 60 years. If we look at a city like Sydney, the average age is changing rapidly because of the urban expansion which also involves a lot of new stormwater infrastructure, say for Melbourne, say for Brisbane. But the average age of their infrastructure is anywhere between 50 and 90 years, depending on where you are in the city. So if you look at that graph, you can see that the loss of capacity we're dealing with. But also, the second side is actually showing something quite important. The density of the city, the hard surfaces, engineers call it the impervious surfaces, don't stay the same throughout the life of a city. So your stormwater infrastructure was designed for a certain density. It's back in the days often when houses had backyards and lawns and trees and things. In the modern era with McMansions and houses taking the majority of your properties, a lot of that green space and trees, unfortunately, and it's become hard surfaces. So that's increasing density of the city, which is the red line showing there with increasing with age, worsens the effect of the reduced hydraulic capacity of the stormwater systems. So you've got a double whammy happening there. You get lost capacity in your existing infrastructure that you're relying on, and your city's getting denser and denser. It's more and more hard surfaces as we're trying to put more people in smaller areas. So your infrastructure is losing capacity, but it's now coping with inputs it was never designed for. So that is an opportunity for changing the way stormwater runs off properties. The outcome of those two issues, of lost capacity in our stormwater systems and increasing density of the cities, is massively increased flooding and rapid decline of waterway health. That means your urban streams, if you still have them, your local wetlands, your local river, your bay, your estuary, they're impacted by these higher stormwater runoff flows that cause erosion and sediment, and also carrying pollution. So there's a lot of pretty poor outcomes from these increased flows in urban areas. Please note it's the opposite for a rural area. So in rural areas we're arguing about losing flows. For instance, in the Murray-Darling Basin we don't have enough flows, and we're arguing about environmental flows and we need more of them. In an urban area we can have far too much flow, which creates all these problems I've just talked about. So it's very important to know the difference between the rural problem of environmental flows and the urban problem of drowning our urban systems in too much water, which is what we're doing.